Hello dear students, in the last class I had given homework at the end of the video. Today let's discuss the homework questions. Along with that, I also explain question answers of the physical and chemical properties of metals and non-metals. So let's start. The first one, that was example of a metal. So any one example, okay, give an example of a metal which is liquid at room temperature, that is mercury. Okay, any one, give any one example. Then which metal can be easily cut with a knife, that is sodium. Or potassium, you can write or potassium, but only one, write only one metal. Which is the best conductor of heat? It is silver. And the poor conductor of heat, it is lead. Okay. The next one, explain the meaning of malleable and ductile. So malleability is the nothing but the metals that can be drawn into thin sheets. Ductile means it can be drawn into a thin wire. Give reason why is sodium, potassium and lithium are stored under kerosene oil. Because since these metals are highly reactive, so when they kept open, soon they react with the oxygen and it may catches the fire. So these metals are kept under kerosene oil. Platinum, gold and silver are used to make jewelry. So mainly because of their lustrous property. Okay, that is a main reason they are used in a jewelry. And also they are less reactive, least reactive metals. They do not react with water and air. And also they are non-corrosive because of its property, that is less reactive. These are less reactive, they do not corrode easily, and also their lustrous property. Due to all these, they are used in jewelry to make ornaments. Water amphoteric oxides, give two examples of amphoteric oxides. So what are amphoteric oxides? Some metallic oxides are react with both acid and base to give salt and water. So salt and water, and these metallic oxides are called amphoteric oxides. Examples, aluminium oxide and zinc oxide. Fifth one, an element that react with oxygen to give compound with high melting point, and this compound is also soluble in water. So which is that element? Calcium, carbon, silicon and iron. Think of all these options. Carbon is non-metal, right? And silicon also. The silicon is semiconductor. But now compare this calcium and iron. Among calcium and iron, which has high melting point? Yes, it is calcium. Calcium is more reactive than iron. And also calcium is easily soluble in water than iron. So the answer is what? Calcium. So this is about the homework questions. Now let's discuss the Q question answers. Page number, it is 46. In that first one, why is sodium kept immersed in kerosene oil? So you refer the answer which is discussed in a homework. Okay, you can refer that answer, because kerosene is a sodium is reactive metal, and if it is kept open, it reacts with oxygen and it easily catches the fire. So it is immersed in kerosene oil. So refer that answer. So I did not give here. The second one, equation for the reaction of iron with the steam. So usually iron, some metals will not react with water. Instead of water, it reacts with the steam. Okay, so iron with the steam. So steam is nothing but the vapor form of water, right? So H2O it is. Then calcium and potassium with the water. So what happens when you pass hot steam to iron, it reacts with oxygen and it forms ferric oxide or iron oxide, Fe3O4, and it is a solid state. Along with that, in that reaction, the hydrogen gas liberates. Clear? The next one is what? Calcium with the water. So since calcium is soluble in water, it forms calcium hydroxide, and it is an aqueous solution. Okay, it is a solution, not a, it is in a liquid form. Then along with this calcium hydroxide, it liberates hydrogen gas. So these are exothermic reactions. Okay, calcium with water and potassium with water. So what do you mean by exothermic reaction? It liberates a heat. Then potassium reacts with cold water, and immediately it catches the fire and it forms potassium hydroxide. Then hydrogen gas liberates. Along with that, it is highly exothermic reaction. So the more heat is liberated and it catches the fire. Okay, in this reaction, the potassium hydroxide that catches the fire. So I mentioned here heat along with the hydrogen gas. And third one, samples of 4 metals A, B, C, D. Okay, here the 4 metals are there, A, B, C, D, but its name is not given. Added to the following solutions. So 4 solutions again, iron sulfate, copper sulfate, zinc sulfate, and silver nitrate. All these are salts. Okay, the results obtained have been tabulated. First one, that is metal A, iron sulfate no reaction, but in copper sulfate displacement, it displaces copper, and zinc sulfate to silver no result at all. Then B, displacement in iron sulfate, and in all the other 3 no reaction. Then C, silver nitrate. In silver nitrate, the displacement reaction occurs along with the silver nitrate. And metal D, no reaction at all. Okay, so based on this table, you have to answer the following questions. First one is what? Which is the most reactive metal? Then the second one, what would you observe if B is added to a solution of copper sulfate? Then arrange the metals A, B, C, D in the order of decreasing reactivity. Decreasing means from higher to lower. Okay, from high reactive metals to the low reactive metals. So to know the answers for these questions, you should know the reactivity series of metals. Okay, reactivity series of metals. So let's see the reactivity series first, and then we'll write the answers. Okay, so reactivity series, here the potassium is highly reactive, sodium, then calcium. So here the given metal salt solution is iron sulfate, and then copper sulfate Cu, and then zinc sulfate, and then silver nitrate. Okay, all these are metals in that salt solution. But in the zinc sulfate, no reaction at all. So just ignore this zinc sulfate. Now see, iron sulfate, copper sulfate, and silver nitrate. Among these, which is most reactive? It is iron, right? Iron, here iron comes, and then copper, and last is silver. So iron is most reactive, that is iron sulfate is. Now go back to the question. So you can see the B displaces the iron from sulfate. That means in these iron is strong, right? Iron is most reactive, but metal B displaces iron from iron sulfate. Then which is the strongest metal here? It is B, no doubt in that. So B is a most reactive metal because it displaces iron from iron sulfate. Why iron is the most reactive? Because it is a highly reactive compared to copper, zinc, silver is actually high reactive metal, but in this zinc sulfate no reaction occurs. So you can ignore this column. Okay. So B is a most reactive metal. That is the first answer. And what would you observe if B is added to solution of copper sulfate? If B is added to copper sulfate, then B displaces copper from copper sulfate because B is stronger than copper. Okay. Third one, arrange the metals A, B, C, D in the order of decreasing reactivity. Decreasing means high reactive metals to the less reactive metals. So here B comes first. And then now think of this metal A, C, D. You have to compare this. You have to say which is the reactive in A, C, D. See, A displaces copper from copper sulfate, right? So here C and D is C displaces silver nitrate. Silver is a least reactive metal. So A comes next, okay? After B, A is a reactive metal, and then C. Why? Because D is no reaction at all. Okay, there is no any reaction when you add D to all these solution. That means D is a very least reactive metal. Okay, let's see the answers now. So B is the most reactive metal, and B will displaces copper from copper sulfate because it is stronger than copper, and this is the decreasing order of reactivity of metals. Let's move on to the next one. Which gas is produced when dilute HCl added to reactive metal? So that is hydrogen gas. And write the chemical reaction when iron reacts with the dilute sulfuric acid. So the answer is hydrogen gas is produced when dilute HCl is added to a reactive metal. So when the metal reacts with acid, always the hydrogen gas liberates. Then the reaction, you have to write the reaction, that is iron Fe, its symbol is Fe plus H2SO4 gives FeSO4 and a hydrogen gas. Okay, this is salt. Clear? Okay, let's move on to the next one. What would you observe when zinc is added to a solution of iron sulfate? And write the chemical equation. Okay, so zinc is more reactive than iron. Therefore, when zinc is added to solution of iron sulfate, what happens? It displaces iron. Okay, then the greenish color of iron sulfate is the color of iron sulfate is green, that fades gradually due to the formation of colorless zinc sulfate solution and iron metal deposited on a zinc. Very easy. See this FeSO4 and zinc. See the metals, okay? Zinc and iron. Zinc is more reactive than iron, so it displaces iron from this solution and it becomes zinc sulfate. And it is a colorless solution. Colorless, green color fades, so that solution becomes colorless, and also this iron deposits on a zinc. Okay, now we'll discuss exercise part, that is page number 56, regarding physical and chemical properties. Okay, chemical properties of metals and non-metals. Metals, even the chemical properties of non-metals are not finished, not over it. We have to explain in the next class. Which of the following pairs will give displacement reaction? Now again we go back to the reactivity series, and all of you take that question, refer the textbook. See which of the following pairs. Okay, sodium chloride solution and copper metal. See copper, where is copper? Copper is here and sodium is here. So sodium, that is most reactive, so it do not displaces copper. There is no displacement reaction occurs. Option A. Second option is what? Magnesium chloride and aluminium metal. Again compare this magnesium metal and aluminium. So aluminium is what? Weaker than magnesium, right? Again here also the displacement do not occurs. Aluminium will not displaces magnesium. Copper will not displaces sodium because sodium is stronger than copper. Magnesium is stronger than aluminium. Then the third option, ferrous sulfate solution and silver metal. See the silver and iron. Again iron is stronger than this silver. So there is also the displacement do not occur. The third option, that is silver nitrate solution and copper metal. Okay, now see here, copper is here and the silver is here. So copper is more reactive than silver, right? So it easily displaces silver from a silver nitrate. So the right answer is what? Option D. Okay, option D is the right answer because copper is stronger than silver. It displaces silver from silver nitrate. All other metals compared to copper, aluminum, silver, sodium, magnesium ion is strong. So the answer is option D. The next one, that is question number 7. Name two metals which will displace hydrogen from dilute acids and two metals which will not. So again you have to refer the reactivity series. Okay, hydrogen, where is hydrogen? Hydrogen is here. Okay, so above metals, what? Above metals displaces hydrogen and these metals do not displaces hydrogen. So the question, what is the question here? Name any two metals which you can write any two from these metals that displaces hydrogen, and the metals which do not displaces copper, mercury, silver, gold. Okay, the choice is left to you. You can write, but write the correct answer. Here sodium and potassium, they displaces hydrogen. You can write magnesium, calcium, then potassium, sodium, or aluminium, zinc, iron, lead. Okay, metals that are less reactive than hydrogen, that do not displaces it. For example, copper and silver. Question number 5. You are given a hammer, battery, bulb, wires and a switch. How could you use them to distinguish between samples of metals and non-metals? Assess the usefulness of these tests in distinguishing between metals and non-metals. Okay, here using all these substances, you must check whether the substance is metal or non-metal. So hammer. So using this, how would you distinguish either the substance is metals or non-metals? Yes, if it is beaten into thin sheets, hammer we can beat, right, by using hammer. Other than that, what can we do with the hammer? No, only we can beat. So when we beat in the substances, if the substances are drawn into thin sheets, then we can infer that those substances are metals. Otherwise they are non-metals. But battery, bulb, wire, switch, what are these components? We can make a simple circuit, right, using battery, bulb, wires and a switch. So just you have already learnt in electricity lesson. This makes a simple circuit. So by using these and connect some substances, if the bulb glows, then that indicates what? The given substance is what? Metal. That means the metals are good conductors of electricity. If the bulb doesn't glow, then the given substance is non-metals, because non-metals are poor conductor of electricity. Okay, let's discuss the answers. With the hammer, we can beat the sample, and if it can be beaten into thin sheets, that is which property? Malleability. Then it is a metal. Otherwise, it is non-metal. Similarly, we can use the battery, bulb, wires and switch to set up a simple circuit. The sample. If the sample conducts electricity, then it is a metal. Otherwise, it is non-metal. The above tests are useful in distinguishing between metals and non-metals, as these are based on the physical properties. No chemical reactions are involved in this test. Very simple test. And this test shows what? Based on what? The physical properties of metals or non-metals. So I hope these questions are clear, and please copy your notes and upload it in the CSAP. Thank you.